Hello and welcome to the second lecture on computational mathematics with Sage Math. In the previous lecture, we started exploring Python programming language. We used Python to do basic mathematical operations such as addition, multiplication, division, finding quotient, remainder, and also raising powers. And using these operations, we also found out compound interest, simple interest, and things like that. In this lecture, we are going to see how we can make use of Python as an advanced scientific calculator. So, we will be making use of two built-in modules or libraries, namely math module and CMath modules. These modules contain functions such as finding square root, exponential, logarithmic, trigonometrical functions, finding GCD, finding factorial functions, and things like that. So, let us get started. So, we will start Jupyter Notebook by going to Anaconda prompt and typing Jupyter space notebook. I have already done that and I have opened this Jupyter Notebook kernel, and these are the files in this directory. Let me open this first lecture. So, if I click on this, it will open the first lecture, and you can see these are the things we did in the last lecture. This file I have saved it in .py format. So, you can go to download and save as .py format. I have already saved it, and this is what you saw in this directory. So, we have python _ lecture 1-1.py. Now, suppose you want to run this file using Python command line, then what you can do is you can go to Jupyter again Anaconda prompt. You can open an Anaconda prompt, and inside this I created a directory. Let us say that directory is called NPTEL lectures, and inside that you have the file python _ lecture 1-1.py. Now, how do I run this file or execute this run this file? You can simply say python space lecture, the name of the file, that is lecture 1 python lecture 1.py, and then when you hit enter, it will show all the outputs that we had in Jupyter Notebook. Okay. So, now let us start exploring Python as an advanced scientific calculator. So, let us start a new notebook. So, let us go to new, click on Python 3, and this is the notebook. Let me again disable this table of content, and let us give a heading. So, let us go to markdown and type one hash followed by, let us say, Python as an advanced calculator, and execute this, that is shift and enter, run this. Okay. So, now let us see, suppose we want to use a square root function sqrt and then sqrt of 2, then it will give you an error because it is not at present built in the standard library. So, we need to import these functions from math module. So, how do I import a module? So, you can say import math. Now, all the functions methods which are available in math module can be accessed by typing math and math dot and then press tab, math dot and press tab. This is advantage of using editors such as Jupyter Notebook or even Spider. All these functions you can get it by dot tab. So, you can see, you can go to this drop down menu, you can see here there are so many functions available, including pi, including log 10, log 1p, log 2 and square root and many other functions are available. So, for example, if I want to find square root, I have to say math dot sqrt of 2, it will give you the answer. Similarly, if I want to make use of sine function, I have to say math dot sine of let us say 2.5. Actually, this is give you the answer. 2.5 here is taken in radian. If you want in degree, you can convert that into degree and then find out the value. So, you can say math dot sine inverse. So, we will say a sine, that is arc sine or sine inverse of let us say minus point let us say 75. Since sine values lies between minus 1 and 1, the argument has to be always between minus 1 and 1. Okay. So, similarly, if you want to find let us say GCD, you can say math dot GCD of two integers. Let us say one integer is this, another integer is this, and then get the GCD of these two integers. Okay. So, if you want to take help on any of these function, you can say help, and I can say math dot, for example, we saw something called log 10. So, let us explore this. What does it say? It says that help on built-in function log 10 in the module math, and how it is used. Log 10 in the bracket you write the value of x and it returns the base 10 of log of x. So, you can try, you can explore all the functions which are there in math module, that you saw what are the functions available. You can even list here by typing dir and then math, you will get list of all the functions. For example, there is something called permutation, PERM and things like that. Suppose we want to explore this function permutation, and you will also see something called combination, permutation and combination. So, let us say we want to explore permutation and combination. So, let us look at how do we do. So, first let me create a subheading called permutation and combination. So, I will get double hash permutations and combinations. Let me run this. Okay. Now, so we want to make use of the two functions, namely PERM and COMB. Now, I do not want to make you always keep on typing math dot PERM, math dot COMB. So, there is a way to import these functions alone, and how do we do that? We can say from math import PERM and com, okay, and then run this. So, now PERM and com functions are available. We do not have to type math dot PERM, we can simply say PERM and it will work. So, let us take a number, let us say n is equal to, for example, 20 and r is equal to, let us say 12, and then we can say permutation of n comma r, and it gives you this value. This is permutation of any 12 objects out of 20 objects. So, choose any 12 objects out of 20 objects and then permute them. This is what you get. And similarly, you can find combination of n comma r, that is choosing any r objects out of n objects. Okay. Now, you must have already seen what are the formulas for permutation and combination. So, combination, when I say NCR, this is equal to n factorial divided by r factorial divided by n minus r factorial, and permutation NPR, this is equal to n factorial divided by n minus r factorial. So, let us try to verify this. How do I verify this? So, we already have a factorial function. So, let me also go back and also add factorial function. So, factorial function, execute this again, and then we can say let us say permutation PERM of n comma r, is it equal to factorial of n divided by factorial of n minus r, and the permutation PERM, okay, the answer is true. Similarly, we can say the combination, that is COMB, combination of n comma r, n choose r, this is equal to, is it equal to factorial of n divided by factorial of r into factorial of n minus r, and the answer is again true. So, we are able to verify this function. Now, suppose we want to find square root of some number. We have not imported square root function, therefore, we need to say math.sqrt, but one can also import all the functions which are available in math module. And how do we do that? So, instead of listing all the functions that you have inside this math module, what you can say is from math import star. So, let us use that, from math import star. Now, all the functions inside math module will be available, star means everything. Okay. So, let us see, if I say sqrt of let us say 4, you get the answer. If I say sqrt of negative of -1, this is math domain error, because this sqrt in math module takes only the non-negative argument. If you want to find square root of negative number, you have to make use of C math module, that we will look at again. So, how do I import? Let us say I will say import C math, and inside this, for example, if you look at C math dot and then press tab, you will see all the functions which are there in math module and some more. So, for example, you can also find square root of -1 using this. Now, let us say C math dot sqrt of -1, you will get the answer. This J stands for I, that is imaginary number square root of -1. Okay. Similarly, suppose I have a complex number z is equal to, let us say 5 plus 3 j, this is 5 plus 3 I, and we want to find out square root of this, then we can simply say C math dot sqrt, and z, you will get square root of a complex number. Similarly, you can find out exponential of a complex number, trigonometrical functions of complex number, and all the functions which are there inside C math module. Now, let us make use of these modules, math module and C math module, to find, let us say, roots of a quadratic. So, let me again create a subheading. I will say double hash, and let us say I will say solving a quadratic. Solving a quadratic. Okay. So, let us take a quadratic ax square plus bx plus c for various values of a, b and c. So, one way is we can define a comma b comma c is equal to some number, let us say 3 comma 5 comma minus 7. So, we are looking at 3x square plus 5x minus 7 is equal to 0, and we want to find roots of this. Okay. So, let us say the first root I call as x1, which is equal to, so we know the roots of a quadratic ax square plus bx plus c are minus b plus minus square root b square minus 4ac upon 2a. So, let us write x1 as minus b plus sqrt square root of b square. So, double star 2 minus 4 star a star c divided by the whole thing divided by the whole thing divided by 2 into a, right. Similarly, what will be x2? So, x2 is equal to minus b minus this, and let us print what are the roots. So, let me again use f string. So, f inside single quote, the roots are x1 and x2, close the single quote. Okay. So, these are the roots of this quadratic function. Now, of course, if you want to keep changing this 3, 5, minus 7, etc., the value of a and b and c, one can do that. Another way of doing the same thing is you can actually ask user to input this from the keyboard. So, how do I do that? I can say a and I can say input. So, you can give also some message here. So, let us say enter a real or enter the value, enter the value of a, enter the value of a. Now, what will it do? It will give you an input box and where you can type the value. Suppose a is 3. Now, press enter. Now, the value of a is 3. Now, let me see what is a. So, a is actually this is a character or 3, this is a character, but we do not want character, we want a real number. So, you need to convert this into a floating point number, or if you want integer, then you can do that. So, how do I do that? Let me again copy this fellow and let me say input, and then we will have to say float, and in the bracket you type the value. Now, let us say this is equal to 3. Now, if you ask what is a, this is a real number. So, like this you can read a, b, c. So, let us read all of these in a single cell. This is a, this is b, this is c. So, here also it will be a, it will be this is b, this is c, and then after this, once you have read this, then let us find out value of this x1, x2, right. So, let me paste it here and print, and then let me execute this. Then you will get, let us say value of a is 3, value of b is 5, and value of c is minus 7. Then you will get the roots. So, this is how you can read the value of a variable using input. Now, suppose let us go and run this again. Value of a is, let us say 1, value of b is also 1, value of c is also 1, and let us see what we get. So, this is x square plus x plus 1 equal to 0, and in this case if you look at b, the value of b square minus 4 ac, this will be negative. So, a square root from math module will not be able to find. So, let us see what you get. So, again you can see here you get an error, and it says that domain error, because this is finding square root from math module which takes only the non-negative real number. So, instead of this, let me go back and change this square root from C math. So, we will say C math dot square root. Here also you can say C math dot square root, and now it will be not a problem. So, 1 1 1, and you can see here it will give you the roots even if the discriminant is negative. Okay. So, later on we will write our own program to print all the roots of a quadratic. It may involve checking whether this discriminant is non-negative or negative and things like that. Okay. So, similarly, suppose you want to find area of a triangle using Heron's formula. Let us say if A, B, C are sides of a triangle, and then we know that area of this triangle is given by square root of s into s minus a into s minus b into s minus c, where s is the semi perimeter. So, how we can do that? We can again we can say copy these input a, b, c. So, let me enter the value of instead of enter the value of a, let me say enter the side a, the length of, or let me say enter a, similarly enter b, enter c, and then after that you calculate the semi perimeter, that is a plus b plus c, the whole thing divided by 2.0, and the area A, capital A, is equal to SQRT. We have already imported that SQRT of S into S minus A into S minus C. The star is important in between. If you do not put star, it will give you an error, into S minus C, and then let us print that. Print the, we will say F single quote, the area is given by this. Let us say this is A, and colon, let me put 0.4. So, it will print 4 decimal places. Close the single quote, and that is it. So, it will ask for, so A is, let us say 3, B is 4, C is 5, the area is I think there is some problem, square root s is a plus b plus c by 2 s into s minus a into s minus b into s minus c. Okay. So, this is let us say 3, 4, 5, then area is this. If I run this again and input, let us say 7, let us say 7, and this is, let us say 9, and this is the area. Right. So, this actually when you write 0.4, this gives you the 4 significant digits, and if you want the 4 decimal places, then you have to say this f. Now, let us run this again. This is, let us say 7, 7, 9, you get this 4 decimal places. So, this f string formatting provides you all these options. Okay. So, try to explore all these functions available inside math module and C math module, go through one by one and see how we can make use of these functions to do various scientific calculations. If you know, if you have seen the scientific calculator, you must have seen other functionality that it has, and of course, this Python will have much better capability than the scientific calculator. So, for example, if I say factorial of a large number, let us say factorial of 100, it computes. If I say factorial of even let us say 1000, then also it gives you the value, right. So, whereas in calculator you may not be able to find factorial of 1000. So, you can explore all the functions which are available inside math module and C math module. But before I end this lecture, let me leave you with some exercises. Let me enter these exercises. So, this is, let me convert this into markdown, and yeah. So, these are the exercises. First, write Python code to input a radius of a sphere and print its surface area and volume. Input a positive integer n and integer k less than equal to n, and verify the following properties, that nck is equal to nck n minus k and the other things. And the third one is input 3 positive floating point numbers a, b, c that can be sides of a triangle, and hence print the area of this triangle using Heron's formula. So, this we have already actually done. So, let me change this. I will say input input, let me say input a complex number and verify some of the properties of so input a complex number z and verify some of the properties of z, or instead of verify, let me say explore. So, you have to make use of CMath module in this case. So, these are the some simple exercises, and you can explore some other computations as well. So, let me end it here. So, thank you very much. In the next lecture, we will look at more on Python programming, especially we will look at how to make use of another built-in data structure like creating a list, creating a tuple and dictionary. Thank you.